Hello, welcome to this next talk, which is held by Rasheed Amir on ship Python apps with Docker. So, welcome.
Okay, good afternoon, everyone. So, we have very good weather, so let's see, we focus on this one or outside, but let's see. Okay, so today I'm going to talk about how we can ship Python apps with Docker. So that's the idea. So before we start, I would like to know that how many of you have tried Docker before? Wow, nice. And how many of you tried real Docker, like deploying into some stage or something? Or okay, nice, production, nice. Anyone has written Docker file? Oh, nice. So and anyone using Docker, like the Docker index, something like that? Okay, good. Nice. And how many of you have been using Docker in your whole environment, actually, like from development to production? Anyone right now? No. Okay. We'll talk today how we can do it, a bit, actually. So it's going to be a quite basic Docker introduction, and not, but we can have questions in the end that you can ask me if you want to ask questions. So that's all. Then a bit about myself, actually. So I'm a co-founder of Aurora, and we specialize in building JVM-based applications. And we specialize in few domains, mainly in media streaming and automated trading. Okay, so here's the agenda. So we'll talk a bit about the background, and then why Docker came in, and then how do you compare a Docker with a virtual machine? So what's the difference? And then how you can create a simple, we'll define the first sample app that we will use during this presentation to run it. And then we will talk about Docker images, how you build them, how you run them, and then we'll talk about Docker index. Then we will try to make some small app and deploy it locally. And then we'll deploy it on the AWS and then deploy on JC if we get time. Okay, so what is the background? Like, if you look into how the market has evolved, you'll find out that if we go back like 2 decades, so we used to have typical client-server thick applications that we used to have, like just one database and then 3-tiered architecture applications just built in one stack. But now, if you look in things, they have changed quite a bit, actually. So now we talk about like microservices. We have small applications. They are like developed by different developers, and then you merge them together. Now you want to use like different kind of databases for different kind of purposes, not just stick with Oracle or DB2. So now things have changed. Like you have the mobile apps. So you want to build really small applications that you want to ship up really fast, actually. So which means it's not about only the development, it's about how you can package and move those applications from one environment to the other environment. So that's how, if you see that how the market has evolved, that things have changed quite a bit now. So, and what is the dilemma right now is that we have like different kind of technology stacks, and we have different kind of databases, we have different kind of messaging queues, and lots of different stuff. And we want to deploy it on different things. Like we want to deploy it on our desktop environments, we want to deploy on data center, a public cloud or private cloud or whatever. So this is really what we want to do, actually. So we have something that we want to deploy on different places. So we want to simplify our life. So this is something called matrix hell, actually. So you understand how you can move things between different environments seamlessly and easily. So we want to solve this challenge, actually. And let's see how Docker can help in that. So I will look into let's talk about in the past. If you look into our life, how things have been, that like in pre-1960s, I think, we used to have a similar problem, that we want to ship stuff from one place to another. If you want to ship like a Porsche from from America to here, you will think about how to move it from different things, like into like in a truck, in a train, or in a ship. How can you move it? So it's a similar problem that you want to do. So they had the same problem, same matrix hell that they wanted to fix. And how did they solve this challenge? In the past, we came up with something called container. So these are well-defined, well-shaped containers that have same standard size. They can fit in on truck, they can come in a ship, or you can move anywhere as you like. So they solve their problem like this, actually. So it's your responsibility to put the stuff into in a container, and then they know how to pick that container and move it in between different, I would say, way to move it like from one place to another actually. So that's how they solve this problem. Now, if we look into this our own IT world, we want to solve the same problem using the Docker container. So the Docker has a similar concept that you ship your whole application inside a container with everything, with your libraries, with your dependencies and everything you put inside a container, and then you ship it from one environment to your all other environments. So you want to simplify the life between, if you still talk about, because we still have this, we talk about DevOps culture, but even then we have operations people who just focus on operation stuff. So we still need to think of a solution that we can easily give them our application code, everything, so they can deploy it on different environments easily, seamlessly, and we can get rid of, it works on my machine. So we typically do that. Oh well, it works on my machine, but well, no, I know it doesn't work there. So it definitely solves the problem of this one actually. So it works on my machine. It works everywhere. So this is how we solve the matrix hell actually. So you move everything in a container. So just give a container and you move it. So this is in short how you can define Docker actually. So you can package your application in a container. Number one, you can build. Number two, you can ship. You can move that container from one to another. And then you can execute that container. So it has everything that you want to execute. And you can run anything on Docker. Believe me, anything that runs on Linux actually. It will run. Even now in .NET, they support through Mono, you can run it on Docker actually. And Microsoft is working quite hard actually right now to support Docker support even in .NET environment, because Docker is Linux-based stuff. So, and you can run it anywhere. Name a pick, I mean anything like local machines, like you can run in your like VirtualBox or everywhere, or in your cloud, private, public, Amazon, Azure, whatever, or even a bare metal, So, and we have tried it like on a bare metal using CoreOS actually, and it's like we have just a server with CoreOS. CoreOS is a stripped version of Linux that only has, I would say, it has only a Docker installation in it and nothing else. It's pretty small, lightweight, and it's very powerful. So we have been using it at different customers. So now the question that really comes in our mind is, well, how is this different from what we have been using, the virtual machines, So like VirtualBox or hypervisor, stuff like that. So the biggest difference in both of them is pretty simple. It's like when you talk about virtual machines, when you boot up a new virtual machine, you have to install what you call it like guest operating system. So you have a host operating system, then you have something called like hypervisor or something like on top of it. Then you create your guest operating system, and then you have your libraries, and then you deploy your apps above it. So it means like you have gigabytes of sizes of image. They're pretty big actually. But the difference in Docker world is actually that you don't have any guest operating system. So what you have is a Docker runtime which runs on your host OS, and then you have pretty small containers which are pretty small in size actually. And they are really small in size depending how you layer them. Like when you make a Docker file, I will talk about later. So you can even share the layers of Docker files between different containers actually, which even reduces the size of the Docker image actually. And then also you can even share the libraries between different apps, which is not possible when you talk about the virtual machine world. So definitely there's a big difference, and it's pretty much fast to make them and move from one place to another. So that's a very high level difference, but you can go in and deep, read more to know about it actually. Now let's get started with Docker, and let's look into, first talk about few basic concepts in Docker. So when you want to start with Docker, you will need to understand these concepts, basic ones. So something is called Docker daemon. This is something which basically manages the containers, which runs on the host actually. Then you have Docker CLI, a way that you can interact with the Docker daemon. And then you have Docker image index, is something like a repository for your images that you can use. So these are the three parts you can say for Docker. So, and then these are the three main elements of that when you make a Docker. So first you have to define a Docker file. So what is a Docker file? Docker file is basically, it's a script for building an image actually. What do you need in that image? You have to specify it. So that's a Docker file actually. First you make an image, and then from the image you can run as many containers as you like. So just consider image as a class and containers as objects of that class. So just like that actually. So you have first container image, then you can run as many containers as you like from that particular image. So these are the basic three concepts that you need to understand. Now if we look into about installation, I'll be talking mainly about how to install on Ubuntu 14.04, but you can run it on Windows, you can run it on Mac. You have to use something, it's called boot to Docker actually, but even then it's pretty simple to. So the installation steps are pretty simple actually. So first you have to add the repository key to your for package verification, then you add the Docker repository, and then you use the simple combo to install the Docker. And this one will definitely get you the latest Docker always. There is a Docker in the, I think, Linux default repo as well, but when you do that one, it doesn't comes up with the latest version of Docker. With this one, you can definitely get the latest version always of the Docker. So now let's look into the small Python, Flask app actually, that we will be trying to run locally. So I hope most of you are familiar with the Flask. I think it's a Python framework for building web-based applications. So we're going to look into a small application that I have. It's a pretty simple structure. I have 3 files. One is application.py, and then requirements, and then the Docker file actually. So if we look into the main application file that we'll run is pretty simple. So it does nothing. It just says, okay, welcome to PyCon Sweden 2015. So it will just return a hello world. So it's pretty small. Then if you look into the requirement.txt, this is the Flask. I think it needs this to, if you want to specify any dependencies to run this application, you specify in this file. And then if you would like to run this application locally, so you have to do all of this stuff. So first you have to set up the Python tools, then you have to install pip. Then you install, using the pip, you have to install all the dependencies or requirements for your application, and then you will run the app actually. So you have to do these 4 steps actually. So similarly, you can have more, but since this is a pretty small application, so you have these 4 steps that you need to do before you can run this application. Now, we want these steps, we have to specify these steps in our Docker file actually. That, okay, when I create this Docker image, I want to make sure that these things are available. So I have the Python tool set up, I should have my requirements installed in it, and then if I run the app, it should work actually. So now if you look into then what is Docker image? So to make a Docker image, you have to first define a Docker file. So let's into the Docker file of this application. Let's walk through it actually. So from Ubuntu, this is the first line, and that's the mandatory. So you have to tell it, okay, which operating system do you want to use to run this application? It could be Ubuntu, it could be Debian, it could be CoreOS, whatever you like. All of them are these are also Docker images actually. So they are available in the public Docker repository that you go and fetch actually. And then I tell him, okay, now create, set up the Python tool actually, then install pip. Then I tell him, because this Docker file is in the same folder where I have the application, so I tell him add the requirements.txt to a particular location within my Docker, which is like source/requirements.txt. So create this location inside the Docker container and move this file into that. And then I can run the pip install to install my dependencies. And then I move my whole application with the add command. So you have like a I think there are not more than 12 different commands that you can use within the Docker file. So it's pretty simple and easy to get used to Docker actually. There's nothing, I don't believe it's a long learning curve actually. If you just spend 1 day or 2 days, you'll be good enough to at least play with the Docker. And then you have to expose the port actually, because Docker is not, you have to tell him, okay, which ports do you want to expose? So I'm telling in this case, okay, expose the port number 5000. And then the last command is cmd. I say, okay, when you are done, and the cmd command is run when you create the container, not while the image is being created. And that's the biggest difference between the run command and the cmd command. Because this really confuses when we start working. Well, this is what's the difference. The difference is cmd gets into action when you actually create the container. So this is the Docker file, and you have similar Docker files for different applications depending what you're using, like Java or Python or PHP or Ruby, whatever you like. You can specify stuff like this. And here's something you need to understand, that all of these commands, when you run them, they just create another layer actually, just like a layer of onion. You can assume like that. So they just create another layer that is got committed to your local repo. So if you share the same layers in different Docker files, so those steps will be pretty much fast because they will be used from the cache. So that's something that you need to understand. It's pretty important. I mean, when you're working with lots of Docker files, this thing really helps to even make this size, I mean, Docker images with even smaller sizes, because you can reuse the layers. Oh, what happened? Okay. Now, how do you make, how you build an image? So to build an image, there's a command called docker build -t. You specify the name of the image, and then you tell him the Docker file path. Okay, where is the Docker file? So you tell him, okay, Docker file is here. So pretty simply, in this case, if I say docker build -t PyCon app and dot. So dot is important because I am telling that I have Docker file in the same path actually. So this will run. I will show you all in the demo as well. So this will run and it will show you, okay, step 0 from Ubuntu, step 1, run apt-get, step 2, step 3, step 4, and then it will show you, okay, successfully built this image and this image is ready. So that's how you build an image. Now, if you want to list all the images that you have stored locally, you can run the command. It's called docker images, and that would list all the images that you have in your local environment. Then you can run. Now this time, if you want to run it now, how you do that? So you have a docker run command. You tell him, okay, I would like to run it in a detached mode with -t, and then you have to specify, okay, map this port of the Docker container to this port in my host machine actually. So you can specify different ports here. So like 5000 within the Docker container and the 5000 on my host. And then you have to specify him the image name actually, what you have given him. So you say docker run 5000, 5000, then PyCon app. So then you will see something down there. It will tell you, okay, here is the container ID that I have started for you. Okay. Then you can go up and play with it. And then you have lots of helpful commands that you can use. You can say docker ps -8 will list all the Docker containers that you have in your machine. Either they are stopped or they are running. So it will list all of them. And then you can kill the Docker containers with docker kill command. Pretty simple to kill a container. And so you can remove a container with the docker remove command. And then if you want to remove an image, you can also do that with the docker rmi command. So this is how you can actually manipulate the Docker containers and the Docker images inside your machine actually. Now let's try to deploy it locally and see if it works or not. So I have here, is this my Flask? Let me go into my Flask sample application. So I have my, if you see here, I have my Docker file here inside it, and this is the same Docker file. And then I have the application file that I want to run. So now if I say docker build -t PyCon app dot. So it shows you this actually. Now this was pretty fast actually because I have already created this image. So it just said, okay, you have all of this is cached already. So if you will do it first time, it will take a bit of time to load because it has to download the Ubuntu image from the I would say from the repository. All of the commands are being run locally, but if you see, this one has been pretty fast and it tells me in the end, okay, you have successfully built this image. And it has run all the commands, and then it's going to cache all of them one by one, as you see here. Now, if you say, okay, I want to see my Docker images, you can say Docker images. So it will list you all the Docker images that you have. So we have 2 images right now. Can anyone tell me why do I see Ubuntu here? Yeah, exactly, because this is one that I'm basing it on actually. So from Ubuntu. So that was when I mentioned from Ubuntu. So this is the one I'm basing it on. So it has downloaded that one as well. So now let's say I want to, if I say docker run -d -p 5000 PyCon app, so it should not work. Why? As the error says, I have another something else running on the same port on my machine, so I need to give him a different port actually. So let's give him 5002. So now you see it told me that okay, this has run successfully and this is your container ID. Pretty one, long one, yeah. So now I have actually, let me move it up a bit. So let's try to run it on a different command now. So here you can see actually that I have the container running. So now what it is now, I have a container of that image that's running locally now. And if I want to actually pull or request that one, I can do that. So let's say curl localhost call 5003. So now it says PyCon, welcome to PyCon Sweden 2015. So that's all. I mean, like this is how you can just run a container, and when you ran the container, it actually ran the cmd command and it run your Python file actually. So you have it up and running now. So that's how you can run it, and then you can use the other commands to like to see the images or to see all the containers. So here I see the list of all different containers that I'm running. So I'm running the same image on different port mapping actually, as you can see here. So 5003, 5002, and 5001. So I have a same image, but I'm running it like in 3 different containers, but I have to map it to different ports actually. So because the host ports they have to be different. Okay, so that's how you can easily run it locally. So now if I say, now if you go ahead and, oh sorry, oh, so I lost the internet. So I think we have poor internet here. So, and I'm just connecting to it, not to my. Oh, can anyone here from? No. So that's not good. No. Well, unfortunately today I ran out of my. Okay, thank you very much. Let me try if I can connect with it. Yeah, thank you very much. Let's see. Yeah.
Yeah, that's okay. That's me. There we go.
Trust maybe.
Yeah. Try to log in some. Just open some page.
No.
So we go Wi-Fi. Is your phone?
Yeah, thank you. Let's see if I can. Yeah, but I don't know. It's not picking up my. Not good. The question is why it's not. Well, let's see. I cannot continue that one. Yes. Okay. I think it came back with. Okay. Seems like it came back with their network as well. So sorry, guys. So I'm glad I'm back. So now we're gonna move on to talk about Docker Index. So what is Docker Index? Docker Index is just like a GitHub actually that we use for our repos. It's something we can use for our images. And you can have Docker Index installation both. You have a public Docker Hub that you can go and use for free, and even you can create a private account. But you can also have a Docker Index running locally inside the Docker container actually. So, and if you go to the Docker Index, you can go there and you can find all the different images. So let's say if I go here Here's the Docker hub actually. So here's a list of, I can go here, I can browse the images that I want to download, like whatever, like MySQL or Postgre, Node.js. You don't need to install anything locally. Just if you have a Docker, you can just download the image from here and you're up and running actually. So similarly, if we look into, I have this my own, I created this image for this Flask sample app that we were talking about. So actually, and this one is linked to my GitHub account, GitHub repo actually. So whenever I make a push to my GitHub, this pulls up the latest repo and then creates a new image out of it, and then it publishes it here. So you can specify the webhooks and everything here, the build triggers, and so it's just like GitHub. So you can use it like that. And if you look here in the top here, it tells you, okay, if I want this image, this is what I have to do actually to get that image. So just like Docker pull, and it's like same concepts like for Git actually, pull, push, commit. You have similar here like pull, push, and commit as well. So now if I want to run this anywhere, I just want to go and I would just say pull, Docker pull. This is the image, download it anywhere, is AWS or Google Compute, wherever you want to do it. Just go and run this command. If you have Docker installed, it will download the image and just run the command and it will be up and running. So you don't need to do anything else, at least this. So let's say if we try to connect, I have an Amazon machine. I hope I can connect to it. Yep. So and I have Docker installed on this one. So just to be sure. Yep. So I have Docker installed on this one. So now if I want to run this application here, I would just go and say Docker pull blah blah this, and it will go and pull it. So let's say it then tries to pull it again, I hope, because it's already there. So yeah, so it told me that it already exists. And if you see these all, these are all the commits actually. It's all the small commits that it has downloaded one by one actually. So since it already existed, so it has told me that it already exists locally. So now I have it. Now if I want to run this, so I can just, maybe I can, I mean if I want to say in Docker, okay, sorry, sure. Now if I say Docker images, I should see the list of images here. So I have this Docker image here. Now if I say I want to run it, so if I say Docker run -d-p 5003 colon 5003 colon 5000, and I need to specify the name of my repository, which is this one. If I just copy it and I come here and I paste it, it should run. So now I have a Docker container. So if I try to go and access this from my browser, it should work actually. So 5003, so it should work. So it says welcome to PyCon Sweden. So I have the app running on Amazon as well. So it's pretty simple if you want to do the same thing. If you have server anywhere in the world, if you can connect it with your Docker index, you can just download the image and you can run it. So it's that simple. And now if we go ahead, so and the important thing is that you can build the images automatically. And we have just walked through our sample repository. So we just tried to deploy it on EC2. I will skip deploying on here because it's the same thing, so we can have some questions. And this is one thing, last thing I want to tell is regarding Docker linking actually. So you can link the Docker containers, because if you talk about real application, you will not just have web app, you will have database, you will have other stuff actually that you would like to link. How do you do that? So you run each thing in a separate container. So you run your app in one container and you run your database in another container. Okay, and you can easily map your drives from your host operating system into the container. Just like you want to run MySQL or anything like MongoDB or something, you can easily map the drives where you want to store them, the file from your host to in the container. So you can simply link the containers from one top of the other and make them work. Thank you. So now it's time for questions. Less time, but thank you. Anyone? Any questions? Yes? Dear? Yeah, okay.
So I saw in the Docker file that there's no version specified for like from Ubuntu and all that. Does that mean that?
No, yeah, it will pull always the latest one.
Yeah,
But
so it might just break because you're rebuilding it, even though you haven't actually changed anything, right?
No, it will always pull the latest one. So if you can go and specify the version if you want to.
Okay, you
so
can. Okay.
Yes, you can specify the version / and you can put the version. So you can version your images and you can download the one you want actually. So
and depend on a specific version
exactly.
of another.
You can do that. Yeah. But if you don't specify, it has a specific. It's called latest. So it will always picks the last one and downloads it. So if you don't specify. Anyone else? Yep, please.
When you said that the Docker index looks like very much like GitHub, does that mean that you can fork? Is this a concept applicable for Docker?
Like fork Docker file, you mean?
Yeah.
Yeah, you can do that. But I mean, you store the Docker files inside your, I would say, in your repo actually. But you just put your images up there in the Docker index. But even if you see there, you can look into your Docker file there as well actually. So I mean, you can of course fork the Docker file, but then you have to rebuild the image actually.
But maybe the similar concept is from specific snapshot of
yes,
the image.
exactly, yeah. So you can do that exactly. So we are, yeah. Please go ahead.
If you're doing this at a company setup and you don't want to use the public repositories, how easy or hard is it to set up your private and secure repository for images and so on?
It's pretty simple. It comes in a Docker container as well, actually. So that's how we are using it, like with one customer right now. So, and now actually Docker is moving. I mean, like previously I had no experience with the customer using in production, but right now we are working with one customer and we are going to use Docker full from development into production actually. And we have auto scaling as well actually. So we are using Azure as the environment. Yeah. And with the local private repos.
So how do you plan to use logging from your production environment?
Well, you can use anything like you're still open to all of the available, I think, Cappuccino or like Chef or whatever you want to use. So you have open options. So right now, I mean, it's not bound to anything. So.
But do you know any good practices for managing logging?
Well, of course, never use username password, always with keys. But I think you can use Chef or Puppet or Salt, anything you like. So
no, but for logging of the application log from your container.
Application logs.
Yeah.
We use Elk Stack for that. You know, Elasticsearch with the Logstash and Kibana. So what we do is right now is that we have like we define our images, our whole containers. We have like 4 different containers inside it. Like one container runs our app. Then we have one container with our syslog actually, so which takes the logs and send to our Logstash common server. And then we have an etc discovery, so we discover all the backend services on the fly. So if I want to know where is the database, so we don't hard code that. So we go to the etc service and ask him, okay, where is my database? And it tells me, okay, you have these many databases. I mean, if we have like in a single instance, it will return me. Otherwise, if it's a load balancer, it will give me a load balancer, and then we can connect. So what we use Elk Stack for all the logging stuff actually. Anything else? Yes, please.
So say I have an image and I'm running it in a test environment and I want to use exactly the same image in a production environment. Maybe some parameters like domain names, etc. that I want to be changed for the production environment. How do I solve that?
Yeah, what you do is like you have something called Docker Compose actually. So you make a compose file and you tell him, okay, where are my dependencies? And you actually specify, okay, I want you to go and look for my dependencies here. Just like as mentioned, we use etcd as a discovery service. So you can build your own discovery service as well. So we specify the discovery service where we pull and ask for our different dependencies that we depend on actually. So you can even parameterize it's called in Docker Compose file, where you tell, okay, because let's say I have a web app, I have database, and I have another dependency backend services. I will make a Docker Compose file. I tell him, run this image and link it with these all different stuff actually. So one of those linked containers is usually our etcd service that tells us where our dependencies are. So we just ask him to find for us actually. Anything else? Or, yeah, please.
Security-wise, I mean,
Yes.
You are exposed of getting. Yeah, security-wise, you are exposed of getting some people access to your core kernel.
Yes, and it depends that how if you have. I'm not that expert, I would say, honestly, in the security part of that, but we do not expose the Docker API outside of our host actually. So you can't access it like simply. I mean, you can easily specify if you want to let your, because Docker can be accessed through an API as well. So we don't expose that part, like anyone can access it. But otherwise, I've never been to an experience where I would say security was or would be an issue. So, so I'm not sure how would I answer it. So sorry for that. Yeah.
So since the Docker images are run in the context that they are destroyed when they're done, as far as I understand, you cannot store any data on the Docker on the Dockers, right?
Exactly, on the containers.
So you have to connect it to a local storage somewhere.
Exactly.
How do you handle that for example, on the core OS machine and in respect to users and separating users and Dockers, so you don't have a problem with security there? Do you understand?
Yeah, I mean, like exactly. So when you kill a container, it means it's gone. So if it has something inside it, it's gone now. So, but what you do is you map volumes from your host operating system inside to your container actually. So where you make the things persistable from your host machine.
But then you need to set up users on your host machine as well. So to keep track of the storage. So really, you cannot just run. You cannot have everything in the staging environment in just the Docker file. You need to have the storage set up somehow outside of that as well for the deployment, right?
Yeah.
Okay.
So that would you make part of some like there where you can still use the chef or puppet or salt stack to do like such kinds of stuff like for you actually. But you have to map, as I said, you have to map the volumes from your host to inside, because when container dies, everything goes away with it. So. And typically, still people are not using Docker too much with the databases at the moment, actually, just for same reason, actually, because you will have to keep data outside of the container, actually. So, and no one is like is changing the database version so quickly. So they're still running databases as it is, but running other of the apps and stuff in Docker, actually, because for apps you have new versions coming up quickly and you want to release them very quickly, but for databases you don't have this problem. You one of a time you upgrade your database, otherwise you say, okay, we are happy it's working. So, but that's a bit of always a challenge with Docker, like mapping volumes and how would you handle it on moving from different environments. Yeah. Yes, please.
So I build a set of services and servers, well, what would traditionally be considered microservices, which have somewhat explicit dependencies between each other. How does this work in a Docker container where if you want to containerize the services separately because they're on a separate release cycle, but you still need this service depends on this service depends on this service in order to do either data availability or similar things?
Exactly. So as I said, what we do is like we have Docker, we link the containers, as I mentioned, that you can link the different containers. And then we specify the backend services in our etcd. Actually, we have a discovery service where we specify all the backend services. So let's say I have microservices A, which depends on B and C. So where are they running? I have to go to the etc service and ask him, okay, give me where is this microservice running. So it tells me, okay, here's the new service. So we use that for discovering our dependencies. So if you heard about 12-factor app, as you can Google it, like 12-factor app. So it's a pretty good thing. So I mean, like 12-factor app. So these are pretty good 12 factors that the Heroku guy who built Heroku, he has written here, and we try to actually follow them in our, which one of them is called backing services. So you keep your backing services discoverable through some like something like etcd or some other solution that you want to use. And that's what we do as well, actually. So we discover them, asking some service. So it's a pretty, and the etcd is just like a key value store that you can use to have your dependencies. Anyone else? Yes,
so you said that it was the first time you used in production.
Still, it's not in the production. It's still in it's the stage right now. So we are actually using Azure to build the images. So we have Azure as the environment.
But why do you think that is that you haven't used it in production more often? Like,
the thing is, it depends on the use case. So the customer I'm working with right now, we are trying it there right now actually. So they have not been using Docker before I was there. So then everyone got excited. So it started. We had a new app actually. So we have they have main couple of things running on the old environment as it is, but they wanted to build a new application to try out. So now we are trying to run it on production. So it's no issues. It should work. Yeah.
Is there any performance issues or
no, never, nothing like that. So because what I said is like we had a use case where we had to support things like Netflix, so we are building a service like that actually for the customer. So we want to have something like auto scaling actually. So when we are using Docker and just to set up the new images of Azure containing Docker and everything baked inside it. So yes, anyone else? Oh, done. No one else. Okay, good. Thank you very much, everyone.
Thank you.